So an eclogite consists of garnet 60% and ompacite 40%. We have an eclogite consists of garnet, it is 60%, and ompacite, it is 40%. And the xmg of garnet and ompacite is given. So xmg of garnet it is given 0.50, and xmg of ompacite it is given 0.75. So I have to calculate the xmg of eclogite. It will be the xmg of garnet and its evidence plus xmg of ompacite and its evidence with 0.6. So xmg of eclogite it will be 0.6. So answer 0.6. Next comes to a Harzbergite contains pure phosphate and pure insertite in molecular ratio of 60:40. So we have an Harzbergite. So it contains insertite and phosphorite. So it is in 60:40 ratio. So phosphorite is 60%. You can say insertite is 40%. So we have to calculate the mole percentage of the MgO in the rock. So first we have to calculate the mole percentage of MgO in insertite and phosphorite. So phosphorite has composition Mg2 SiO4. Then insertite has composition Mg2 Si2O6. So first we will calculate the moles of moles of MgO in phosphorite and moles of MgO in insertite. So first moles of MgO in phosphorite. So phosphorite it has MgO 1 mole and SiO2, 2 moles of MgO and 1 mole of SiO2. So mole percentage of MgO will be moles of MgO, that is 2, and total mole will be 3 into 100. Then we'll calculate the mole percentage of MgO in insertite. So insertite has composition Mg2 Si2O6. So it has 2 moles of MgO and 2 mole of SiO2. So mole percentage of MgO will be here. It will be moles of MgO 2, total mole 4 into 100. So now we'll get the mole percentage of MgO in phosphorite and in insertite. So we have to calculate the mole percentage of MgO in the rock, that is Harzbergite, which consists of phosphorite and insertite in 60 and 40%. So the mole percentage of MgO in a rock, it will be the mole percent of MgO in phosphorite and its ratio, that is our percentage, that is 60%, 0.60, plus mole percentage of MgO in insertite and its percentage within the rock, that is 0.40. It will be 60. It will be 60. The mole percentage of MgO in the rock is 60%. The muscovite has the following composition in which iron is ferrous, Fe2 plus. The amount of Al in the tetrahedral site is dash. We know the general formula of mica, that is X, Y, 426, Z, 8, O20, OH, whole 4. X2, Y426, Z8, O20, OH whole 4. So here we have taken half in every side. So for this it becomes X1, 4, 3 to 4, 2 to 6, Z, sorry, 2 to 3, Z will be 4, O 10, OH 4. So K place is fill up, the X place is fill up, that is 1. Now this place here iron is 2 plus, so when iron is 2 plus it will occupy the octahedral site. And here the SI place it should be 4, but the SI place is 3.25. So how many more it will require? 3.25, that will be 0.75. So 0.75 amount of aluminum will be present in the tetrahedral site. So it will be like this. So formula K, your Fe 0.25, then your Si 3.25. Here aluminum are present 0.75. So it will be add up to, you can say, 4. Then rest of the aluminum, there is 1.25. One second. The rest of the aluminum, that is aluminum 1.75, it will be in the octahedral set. So this will be add up to 3, and this will be 1, this will be 2, and here it will be 4. So to satisfy the formula, so Al 0.75 part will be in the tetrahedral site and 1.75 part will be in the octahedral site. So the weight loss during the conversion of 1 mole gypsum to anhydrite is dash percent. So gypsum have chemical formula CaSO4 the 2H2O. When it is converted to anhydrite, this CaSO4 plus 2H2O. So here 1 mole of gypsum it is converting to 1 mole of anhydrite. So I have to calculate the weight, and then we can calculate the loss of weight. So you can see here CaSO4 plus 2H2O when converting towards CaSO4, this much weight is loss, that is 2H2O amount of weight is loss. It is separated from the gypsum. So anhydrite it is dehydrated. So this much is actually lost during the conversion of 1 mole of gypsum to anhydrite. So we have to calculate it in percentage. So first we have to calculate the weight of CaSO4 dot 2H2O. So CaSO4 that is given 40, sulfur it is given 32, into oxygen 4, 16 into 4, plus, then plus 2H2, that is 4 into 1 plus 2O 2 into 16. This is the weight of the CSO4.2H2O or gypsum. It will be, the total weight will be 172. So 172 is the weight of gypsum. When it convert to anhydride, this much weight is lost. That is your 36 gram. So this much weight is lost. So what will be the ratio or percentage? 36 by 172 into 100. This much is lost during the conversion of gypsum into anhydride. Will be 20.93%. 20.93% is lost during the conversion of 1 mole of gypsum to anhydride. Then the indices of refraction of an uniaxial section are epsilon and omega is given. So epsilon it is given 1.653, omega it is given 1.544. The retardation between the two rays it is given, retardation it is given 550 nm. So we have to calculate the thickness in micrometer. So thickness is asked in micrometer. So you put the formula retardation, that is retardation equal to thickness into birefringence. So retardation equal to thickness into birefringence, that is high refractive index minus low refractive index. So retardation it is given 550 nm. Thickness we have to calculate, and 1.653 minus 1.544. Like 550 nm divided by 0.109. So this will be 0.109. So T will be 5045.871 nm. This is the thickness. So we have to convert this nm into micrometer. So we know 1 nanometer is equal to 10 to the power minus 3 micrometer. So it will be 5.045 micrometer. Answer will be 5.045 micrometer. The crystal lattice parameter are given. So lattice parameter are given. So write down in ABC sequence: 4.26 angstrom, 10 angstrom, then 3.44 angstrom. Then the intercepts are given: 2.13 angstrom, 10 angstrom, and 1.72 angstrom. So we have to calculate the Miller indices. Miller indices. So it will be, you can say, lattice parameter divided by your intercept. Or you can say unit length by intercept. So 4.26 divided by 2.13, then 10 by 10, and 3.44 divided by 1.72. Will be 212. So Miller indices will be 212. Then in the overwhite granite, so overwhite has chemical composition of Ca3, Cr2, Si3, O12. Ca is 2 plus, Cr3 is 3 plus, Si 4 plus. So Ca is in cubic coordination. So coordination number of Ca it is given 8. Cubic coordination means 8-fold coordination. Cr is given octahedral coordination, that is 6, and Si coordination number is given 4. So electrostatic bond strength of calcium, we have to calculate the electrostatic bond strength of calcium 2 plus. So electrostatic bond strength, it has a formula of valency divided by coordination number. So for calcium, the valence is 2, coordination number is 8. It will be 0.25. If the intercept of the crystallography axes are 0.5 A, 1 B, 0.7 C. So intercepts are given right down in terms of ABC, 0.5, 1, 0.75. So you have to calculate the crystallography plane scale, the value of L. So you just take the reciprocal 1 by 0.5, 1 by 1, 1 by 0.75. So it will be 1 by 0.5, it will be 2, then 1, then it will be 4 by 3. So to simplify this, we will multiply 3. So it will be 6, 3, 4. 6, 3, 4. So 6 is H, then K, then L. So L will be 4 here. L will be 4. Answer will be 4. The density of a FCC unit cell, it is given 6.5 gram per centimeter cube. If the mass of a single atom is given here, then the diagonal length of the phase we have to calculate. So the density of the unit cell has a formula, that is rho is equal to mass into number of atom present within the unit cell divided by Avogadro's number into volume of the unit cell. So Z here indicates number of atom in unit cell. Here FCC, so Z will be 4. Then M is your mass, it is given 60 gram. Then Na Avogadro's number, it is given 6.022 into 10 to the 23, and A is the side of Q. Side of Q. So rho is given 6.5 gram per centimeter. So we'll put the value now, 6.5, then your 6.5 gram per centimeter cube. Then mass is given 60 gram into 4 divided by 6.022 into 10 to the power 23 into AQ. We have to find out the side. So it will be AQ is equal to 60 into 4 divided by 6.5 into 6.022 into 10 to the power 23, this much centimeter cube. So here question is asked in answer is asked in angstrom. So we have to convert this centimeter cube into angstrom cube. So the 1 centimeter is equal to 10 to the power 8 angstrom. If you convert this centimeter cube, that means 1 centimeter cube, it will be equal to 10 to the power 8 angstrom cube. Okay, so you can write down here also. First we'll solve this part. It will be this much, 6.131 into 10 to the power minus 23 into 10 to the power 24 angstrom. 10 to the power 8 the cube, that will be 10 to the power 24 angstrom. Okay, so you can write down here 6.131 into 10 angstrom. So AQ will be 60.31 angstrom. So A will be cube root of 60.31 angstrom cube. So it will be 3.921. So this will be the side. So if you know the side of the cube, we can calculate the diagonal. So diagonal will be root 2a. So root 2a, So it will be 5.54 angstrom. The answer will be 5.554 angstrom. That is the diagram. If a mineral with formula KAl3Si3O10FOH So it's the same general formula. You can write down X, Y22, 3, Z4O10, OHF whole 2. So your F is 0.5. So how much required for 2? So it will be 1.5. So OH will be 1.5. Then the atom percent of Fe in pyrohotite. So atom of Fe, it is given 0.77 S. So number of atom of Fe, it is 0.77. Number of atom of sulfur, it is 1. So number of percentage of Fe atom, it will be 0.77 divided by 1.77 into 100. Will be 43.50. Then the mole fraction of phosphorite in olivine with MgO 29.17 weight percentage, FeO 34.65 weight percentage, and SiO2 36.18 weight percentage. So we have to calculate the mole fraction of phosphorite. So MgO weight percentage given to 29.17. Then FeO weight percentage it is given 34.65. So first we have to calculate the moles of phosphorate, moles of MgO and FeO. First will be moles of MgO here. It will be given mass, that is 29.17 divided by molar mass, it is 40.31. Then we have to calculate the moles of FeO, given mass 34.65 divided by weight is given 71.85. Moles of MgO will be 0.7236, moles of FeO will be 0.4822. So then we will calculate the mole fraction of phosphorite, will be 0.7236 divided by 0.7236 plus 0.482 will be 0.59. So the mole fraction of MgO will be 0.59. So that is indicate the phosphorite. For an anisotropic crystal, thickness is given 0.04 mm. The refractory index, either N1 is given, will take 636, and N2 it is given 1.486. So the retardation will be thickness into birefringence, N1 minus N2 will take here. So thickness is given 0.04 mm into, it is given 1.636 into 1.486. So this will be minus, sorry. So 1.636 minus 1.486, it will be 0.006 mm. But answer is asked in nm, so it will be 6000 nm. Because 1 mm is equal to 10 to the power 6 nm. Answer will be 6000 nm.